The reason for seasons. Please use the note sheet provided to you in class. If you have not read the note sheet before starting the video, please make sure you pause the video now, read through the note sheet to see what kind of notes you'll be asked to take before you continue on with the video. This will help you. Or pause the video as you're going through to make sure you get everything that you need. So Seasons Lab, please take out your Seasons Lab and listen as I discuss some of these questions. The answers won't necessarily be discussed, but some thoughts and ideas will be. You should be writing down some of your ideas about why these things were incorporated into the lab. So first off, there were 4 stations, A, B, C, and D. What does that mean in terms of the season? Think about why I used 4 globes instead of just 1. We only have 1 Earth, but why was I showing you 4 Earths? And their tilt was sort of all in the same direction, or their axis was all pointed in the same direction. That is really important to remember. Think about why you are measuring north and south of the equator. That is really important when determining which season a hemisphere is currently experiencing. How much sunlight is really important to that hemisphere and what it is getting in terms of indirect or direct sunlight. And then what season did each station represent for the northern hemisphere? So if you've already started the conclusion to your lab, you'll notice there's a chart, and you should sort of be able to figure out what season the northern hemisphere was in for each of the stations based on your notes for your drawings and the amount of sunlight that you measured. So jot down some answers to these questions on your note sheet and then continue on to the next part of the video. So some important points from the lab is the tilt of the globe. It always remained tilted in the same direction. All 4 stations, the globe was tilted towards the side of the room or the whiteboard when you first walked into the classroom. So that is important. The Earth is always tilted towards the North Star, which is Polaris, and it'll be tilted there for a really long time. If you're interested in the North Star and why we are tilted towards the North Star, there's a website that you can look up. It is located under interesting websites. The amount of light that covered the globe changed depending on what season the globe was experiencing. Okay, so think about how long photoperiod is at a specific time of the year, especially here in Salem. If the photoperiod is long, what kind of season did we have? Can we expect there's a lot of sunlight or a little amount of sunlight? And then Earth's revolution. If we didn't revolve around the sun, then we wouldn't have a change of seasons. So that's the point of sort of having the 4 globes, to sort of show you what it would look like for Earth to revolve around the sun and be at those 4 different distinct locations. So the changing of the season. The Earth is tilted at 23.5 degrees. And that is important. If you remember from class, we discussed that the Tropic of Cancer is 23.5 degrees north of the equator, and the Tropic of Capricorn is 23.5 degrees south of the equator, which is really important when we get to whether the northern hemisphere is having summer or when the southern hemisphere is having summer. And those 2 lines of latitude are really important, and that is sort of what helps us determine that we have summer in the northern and southern hemispheres. So again, the axis is always tilted with the North Pole pointing towards Polaris, or our North Star. Because of this tilt, the angle or intensity of sunlight changes throughout a year. So as Earth is revolving around the sun, the angle of sunlight changes, whether we get direct sunlight, which would mean really high intensity, so a lot of sunlight, or indirect sunlight, which means low intensity, or the sun is just not as bright and not out as long a time during the day. So because of Earth's revolution and the tilt, which increases or changes the amount of sunlight we get, that changes our range of photoperiod. As you move further and further away from the equator during Earth's revolution, the range of photoperiod changes. It increases. So the further north you are during the summertime, those photoperiods can be really long, and in the wintertime, they can be really short. In the same with the south, the further you are south of the equator, in their summer, the photoperiods will be really long, and then in their winter, the photoperiods will be really short. However, remember, if you're at the equator, photoperiod rarely changes. So, tilt continued, because the tilt of the Earth is really important to what causes the seasons. If we didn't have the tilt, we wouldn't experience these changes in seasons. So the angle of sunlight determines which season you will have. So with the tilt, if the sunlight is directed towards the Tropic of Cancer, which is 23.5 degrees north, you will experience summer. If the sunlight is right on that line of latitude, you will have summer here in the northern hemisphere. As the Earth continues to revolve around the sun, you'll notice that sunlight will change, and the sunlight will be mostly directed at the equator. The sunlight is directed at the equator during our equinoxes, which we have in September and in March. So that's when the sunlight is directed at the equator. During the northern hemisphere's winter, however, the sunlight is directed 23.5 degrees south of the equator, or at the Tropic of Capricorn. Here's my fun little drawing that is not to scale, but shows you what is happening in terms of the angle of sunlight in the northern hemisphere's summer. So it's exaggerated, and you can see that there are several arrows pointing towards the northern hemisphere, showing that the intensity of sun increases with our summer. And then the arrows at the southern hemisphere, or below the equator, there aren't as many right here. There are only a couple of arrows, and that shows you that there's indirect sunlight. So the arrows are, or the sunlight rays are spread out, so we don't get as much sun, or it's not as intense, so it doesn't heat it up, hence the cool temperatures. Revolution is an important part. I said earlier in the video that if we didn't have revolution, we wouldn't have seasons, or we wouldn't have a change in the seasons. So we experience the 4 seasons because Earth revolves counterclockwise around the sun. And because of that and our tilt, we are able to experience summer, fall, winter, and spring. So putting it all together, this is a quick little sentence that kind of summarizes it very concisely and together, that the tilt leads to the angle of sunlight changing throughout Earth's revolution. Yes, there's a lot more detail, so what I'd like you to do now is begin to put it all together and explain what causes the seasons in your own words.